Go ahead.
Well, welcome everyone to part 2 of this. I'm going to be having 2 main subjects tonight. One of them is going to be talking about fine-tuning, and the other about scientists of faith. And fine-tuning is sometimes gone by another name, and it sometimes is called the Goldilocks effect. And if everybody remembers the story of the 3 bears and the little girl went to this cottage and she found 3 bowls of porridge, and she found the one that was just the right temperature, wasn't too hot, wasn't too cold. And then there were 3 beds, and she found just the right one. It was not too hard and not too soft. Well, that's used to describe the universe and the world in which we live, that we live in a just right universe. And this started seriously being taken in research in the mid-'80s, actually. And John Barrow, you can see his book here of 2002, he wrote a very seminal book in 1986 with another fellow. And it started talking about how finely tuned the universe is. And you can see this other book by Paul Davies. He's a scientist that's written a lot about God and science. And he actually called it the Goldilocks enigma, getting back to the fairy tale, or the cosmic jackpot. So that some people think we've won this cosmic lottery because everything is so just incredibly just right for us. A more recent book, which actually I was led to relatively recently, and it's a wonderful book, very readable. The authors, they don't use many equations. It's a very readable book. And Luke Barnes is an astrophysicist from Australia. And it's basically, they go all through all the different aspects of how we live in a finely tuned cosmos. And he put out a paper, Luke Barnes, a few years earlier, a scientific paper that was peer reviewed. And there you can find lots of math equations if you're so inclined. But they show how the terrible consequences if the constants that determine our universe are changed. And it's generally bad news for anybody who wants to live there. So as I said, many properties are just right. And I'm just going to give you a few examples. So the distribution of matter in the universe, if it was too lumpy, gravity would attract these lumps and crush them together, and the universe would be full of just black holes. Hard for life to exist in such a universe. And if the distribution was too smooth, there'd be no galaxies at all. And if you look at the picture, this is actually a computation of the matter in the universe, and you can see there's filaments, there's threads. It is lumpy, but not too lumpy, such that galaxies were able to be formed, planets, and so on for us to live on. Everything with mass in the universe is attracted to each other. And Newton was the one who came up with this law of gravitation, that everything is attracted to each other. That's explained all the orbits of the planets around the sun. And there's a constant there called big G that determines how big this force is of attraction. And if that was bigger than it is now, the stars would be too massive. Too much matter would clump together, and you wouldn't get any livable planets. If that factor G was smaller by just a bit, the stars wouldn't be big enough. The stars would be too small, and you wouldn't have any heavy elements in the whole universe. It'd be mostly hydrogen, helium, the very, very light ones. One of the other forces, fundamental forces, there's 4 of them. Gravity's one. A second one is the strong force, so-called. It keeps the neutrons and the protons in the nucleus of all our atoms coupled together. Because all the protons you have in your nucleus of your atoms, they're all positive. So they should all just fly apart, because 2 positives, like 2 north poles of a magnet, separate. It's only positive and negatives that attract one another. So we have all these positive things inside our nucleus, and yet they don't fly apart because they're bound by this strong nuclear force keeping the nucleus together. And if that strong nuclear force was just a few percentages bigger, it'd be so strong that you wouldn't have any light elements, because all these protons would want to stick together and create very, very big ones. If that strong nuclear force wasn't strong enough, you would have only hydrogen. Protons wouldn't stick together, and neutrons to form heavy elements. So it's that strength of that strong force is just right. After the Big Bang occurred and everything just flew off, scientists have realized, to even more and more precision now, compared to when they first started looking into this, how just finely tuned that expansion of the universe was. And you can see here, if it was smaller by 1 part in a million times a million, if things didn't expand fast enough, gravity would have pulled everything back together and it would have collapsed. But if that, by the same token, if everything expanded away too fast, and here you can see by 1 part in 1 million, everything would be flying apart so quickly from each other that nothing would clump together and you wouldn't get galaxies. So that rate of expansion is very, very finely tuned. The mass density of the early universe is related to what I just said. And this comes from that Luke Barnes book. He's saying a second after the beginning, that mass density had to be very precisely this crazy big number of 10 with 24 zeros after it, kilograms per cubic meter. And I think even Malad wouldn't be able to lift this. I've seen Malad lift some very, very heavy bags of cement. But even Malad could not lift this.
Yeah, I can. Maximum ridiculous.
And if that density was larger or smaller by just by 1 kilogram per cubic meter, we would still, again, not have any galaxies formed. And 1 kilogram out of 10 to the 24 kilograms, that's an exceedingly fine number, exceedingly small number, 1 part in 10 to the 24. Albert Einstein here, with his crazy hair, one of his pictures. He came up with this cosmological constant in his theory of general relativity. And this constant, he didn't like it, actually. He actually fudged it a bit, and later he said it was one of the biggest mistakes of his life, because his equations that he came up with pointed to an expanding universe. And I talked about that a bit in the first part. But physicists now have a consensus, basically, that degree of fine-tuning for that constant in his equations is even bigger than the last one I mentioned, 1 part in 10 with 90 zeros after it. And that's just ridiculous. And just for comparison's sake, I don't know if you know how many atoms are in the universe. They estimate how many atoms are in the universe. It's 10 to the 80, 10 with 80 zeros behind it. So that fine tuning in this constant is stronger than if you painted one atom of in the universe a very unique red color, and you wanted to randomly pick one atom out of the whole universe. The odds are of picking that one unique one, well, the fine tuning is higher than that. So that's just mind-boggling. So that's some of the constants in the universe, but we also live in a just right solar system. Basically, our solar system is 26,000 light years from the center of the Milky Way galaxy. And if we were closer to the center of the galaxy, they've now proved, and actually just in the last couple of months, actually there was a Nobel Prize given this year for the scientists that were able to image the massive black hole at the center of our Milky Way galaxy. Somehow they were able to filter through all the stuff and image the black hole at the center of our galaxy. If we were too close to the center, the radiation would be just intense. We wouldn't survive. And all the extra gravity and mass there, we wouldn't have a stable existence. If we were too far away from the center of the Milky Way galaxy, our galaxy, there wouldn't be enough heavy elements for us. Our planet Earth would not be the way it is. So we are just the right distance in our Milky Way. And our Milky Way galaxy is like a disk, like a Frisbee disk. And we're not above the disk, we're not below the disk, we're kind of in the middle. And all that material protects us from all that radiation that's coming from the center, basically. So we're just in the right spot. Well, this is a hot topic today. Sorry to use that. I didn't mean to use that pun. But even the Earth's surface has to have just the right reflection. We're getting bombarded with, a kilowatt per square meter from our sun. We need to absorb some of that energy, but we also need to reflect some of it away. Otherwise, as we hear about, we're going to have a greenhouse effect, like on the planet Venus, and temperatures will just start to rise. The ozone level in the atmosphere, if there's too much, ozone basically absorbs all that harmful ultraviolet light from the sun. But that's a source of heat for the Earth. So the Earth's temperature would drop if it was too much. If there wasn't enough ozone in the atmosphere, in the higher atmosphere, we'd be wearing sunscreen 5,000 if to go outside. A lot of ultraviolet light. The mass of our sun, if it was bigger, it would burn up too fast. Of course, I'm talking, when I say fast, it's not tomorrow. It's we're about halfway through our sun's cycle. The sun's about 5 billion years old, and we're in a very stable part of its life cycle, thankfully, because the solar flares aren't too bad. If the sun was smaller, we'd be closer to the sun in order to be in that habitable zone. I'll talk about that in a minute. And we might have tidal problems like the planet Mercury. The planet Mercury always shows the same face to the sun when it rotates around it. and life would not be possible there. The color output of the sun, different stars give out different wavelengths of radiation. And the output of the sun is just right for photosynthesis to occur in plants, a critical factor for life. It turns out that Jupiter and Saturn, they're like our big brothers in the solar system. They basically, if you take the mass of the sun plus the mass of Jupiter, that's 99% of all the mass in the solar system. Us and all the other planets are less than 1% of that mass. And what Jupiter and Saturn do is they sweep around the sun, is that they pick up comets and meteors that are flying into the inner solar system and protect the planet Earth from being bombarded too much. The distance from the sun, I mentioned this. One of the things they're looking for, and I'll talk about exoplanets in a second, is for liquid water. And we're about 2% of that range, within 2%. Otherwise, if we're too close, there would be no liquid water, it'd be all evaporate away. Too far away, it would just be ice. One of my heroes in this whole area is Stephen Meyer. He's a geophysicist. He was a college professor. He now is at the Discovery Institute. They have a great, they email out stuff once a week. And he's been one of the original key proponents of the whole intelligent design movement, or ID they call it for short. A couple of his big books, The Signature in the Cell is a big thick book about DNA and how just intricate the cellular mechanism is. Darwin's Doubt in 2013 about the problems with blind evolution coming up with everything we see around us. But in just last year, he came out with this new book called Return of the God Hypothesis. And it's very readable. It gets a little deep at times, but he called it this because an atheist scientist came out with a book called something like The Failure of the God Hypothesis. And so he actually addresses a lot of what that atheist said in this book, and he called it The Return of the God Hypothesis. He has these three scientific discoveries that he elaborates on are one, cosmology, which is basically how everything started, the beginning of everything. The second one is the incredible fine-tuning. So he talks in much more detail. I'm just touching the surface here of fine-tuning. And then biology. He's really a pioneer in talking about the information content of DNA and how it's like a computer program, and hence there must be a designer behind it. So, and Meyer referenced a scientific publication by the fellow I mentioned before, Luke Barnes, Australian astrophysicist. And this is just one example in his paper, The Fine-Tuning of the Universe for Intelligent Life. So what they did is they looked at all these various parameters, and here we have the mass of a couple of quarks going up and down on the two axes, and they explain what happens if you change those two masses. And I can't go into the details, but essentially you see this little green area in the center where the black dot is us, the masses of the quarks as we've measured them. But if you change those masses, the only viable life permitting place is this little green area here, little triangle. And if you go outside that, life would not be possible. So it's just an example in this case of how everything is fine-tuned. And I'd like to add, this is a peer-reviewed scientific paper that he wrote here, a very good review of the area. So it's not just in popular literature that people are talking about fine-tuning. It's in the scientific literature. Dr. Hugh Ross is another one of my heroes, has been for a long time. He's the founder of Reasons to Believe. He actually got his PhD at the University of Toronto. Some of his books, The Creator and the Cosmos, and then Improbable Planet. He gets into the history of the planet Earth and just all the so-called coincidences that occurred over the history of the planet that made it just the right conditions for us to be living here at this time. That's even beyond fine-tuning. It's also showing the providential character and actions of God to prepare everything for us to be here at this time. In one of his books, he listed like 140 different fine-tuning examples. He talked about this a long time ago as well. And I've just, there's 65 of them here on this page. It's just so many, so many of the constants of nature that have been finely tuned for us. And Hugh Ross goes into talking about exoplanets because it's quite in the news now. And actually, 3 years ago, the Nobel Prize in Physics was given for the first discovery of a planet outside of our solar system. That was in the mid-90s. But they believe they've found, 4,000 to 5,000 now exoplanets. They're really seriously looking for them. And as we mentioned before, one of the primary conditions is basically the presence of liquid water. You can see if you're too close, you're too hot for liquid water. If you're too far away, it's too cold. And the just right is just in between. But beyond that simple one of liquid water, there's like 6 other conditions. The right amount of UV radiation. We talked about ozone earlier. Just the right conditions for photosynthesis. And those right conditions bring in a lot of other factors: humidity, temperature, seasonal variation, and so on. The amount of ozone, we mentioned that. The rotation rate of the planet to maintain clouds for proper life cycles to occur. The actual planet should be tilted slightly when it rotates. Prevention of, we mentioned tidal locking, keeping that from happening. Because some of these exoplanets they found are basically orbiting around very massive stars because they're the easiest ones to find. And some of them are very close to their star. The solar wind to protect us from cosmic radiation. So our Earth, despite them saying that they found all these other exoplanets, there may be life on these other planets. That's possible. Whether it's only microbial life or bacterial life, it's a big step to get to intelligent life. But there's a lot of conditions for life to be viable, not just liquid water. So we will see what they come up with in the future. And basically, of those 5,000, they range from about 4 to 40 light years away. It's just amazing that they can see these things, but they're getting very precise in their instruments. But yeah, less than 100 are in that just the right distance for liquid water, but liquid water is not enough. It needs many more conditions. So our planet Earth, and this is someone else wrote a book called The Privileged Planet. We indeed are in a very privileged place in the universe, a very special place. Arno Penzias, he and his collaborator won the Nobel Prize in 1978, because they discovered a way to measure the remnant from the Big Bang explosion that occurred 13.8 billion years ago. There's basically, it's 3 degrees Kelvin, this microwave background radiation, or cosmic background radiation, they call it. And he says this, in summary, astronomy leads us to a unique event, a universe which was created out of nothing. One with the very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say, supernatural plan. Thus, the observations of modern science seem to lead to the same conclusion as centuries-old creation's beliefs. I'm just going to play this short clip. It's where an advertisement has used fine-tuning. Turning up my sound a bit. Hope you can hear this.
13.7 billion years ago, when all was just a vast expanse of nothingness, we had around one chance out of 2 land. One chance out of 300 trillion that the Earth would be at an optimal distance. 600 billion is that there would be water, nitrogen and carbon in the exact proportions for life to develop and give us a chance to survive. We had one chance out of billions of billions for the Greeks, the Romans, the Celts, the Germanics, the Huns, the Vikings, the Ottomans and others to fight and intermingle for hundreds of years to create the Europe and trillions that after generations and generations your father and your mother would meet. You're incredibly lucky, but it may not last.
Oops, sorry about that. Anyway, I couldn't resist that video. I always enjoy that one. And of course, it's not all fine tuning. It's also some of the history on the planet. You know, seeing the dinosaurs there, I could go into more detail on this, but basically it was that asteroid that struck the Earth 66 million years ago that basically wiped out the dinosaurs. Well, the mammals would not have had a place to be here. They were kings of the planet for millions of years. And this one event allowed other species to take over eventually. So anyway, that's another story. Okay, so I want to go on to the second part B of part 2, and that's talk about some scientists, because people think that scientists cannot be religious or should not be religious, but let's look into that. This list here is some of the early scientists who were believers. And most of you will recognize most of these names. I mean, some of them may be not known to you, but Isaac Newton. And all of these people were geniuses. They started whole fields of science. You know, Galileo, Copernicus, of course. And you can see their affiliation on the far right. So there was a reason for this, because believing scientists believed in a rational God who set up laws in the universe, and they believed that God gave us rationality and minds to figure out those laws. And that's why science grew in the West, in the Judeo-Christian milieu. Well, there's a logical fallacy called the ancient fallacy, and that's, well, they lived such a long time ago. You know, we know so much more now, so we don't have to, you know, have that have any weight for us because they were, you know, lived centuries ago. Well, let's look at some more modern scientists. These are all, the Nobel Prize was in physics was first given out in 1901. And in the 20th, so it started in the 20th century, and these are all Nobel Prize winners in physics who believed in God. The ones in yellow there are particularly dear to my heart because Towns and Shallow, they basically were instrumental in the invention of the laser, which was my field for 35 years. And I'll talk about William Phillips in a second. Arno Penzias, you can see near the bottom there, he's the one we quoted before. And here is Charles Towns. He died a few years ago. He invented actually not the laser initially, but the maser, which was a microwave. Instead of light waves, they used microwave. So that the maser was invented before the laser. That's another detail, but he won the Nobel Prize in '64. And he says this: intelligent design as one sees it from a scientific point of view seems to be quite real. This is a very special universe. It's remarkable that it came out just this way. If the laws of physics weren't just the way they are, we couldn't be here at all. The sun couldn't be there. The laws of gravity and nuclear laws and magnetic theory, quantum mechanics, and so on have to be just the way they are for us to be here. So that's basically a fine-tuning behind all that. Well, all these Nobel laureates, they didn't all believe in the Christian God, but there were many on the list that were. And another one is William Phillips. It was in 1997 that he shared the Nobel Prize for being able to come up with a way to cool and trap atoms with laser beams. And he says this: why do I believe in God? As a physicist, I look at nature from a particular perspective. I see an orderly, beautiful universe. I see a universe that, had it been constructed slightly differently, would never have given birth to stars and planets, let alone bacteria and people. And there's no good scientific reason for why the universe should not have been different. Many good scientists have concluded from these observations that an intelligent God must have chosen to create the universe with such beautiful, simple, and life-giving properties. And it just brings me back to the scripture, Psalm 8, verse 1. O Lord, our Lord, how majestic is your name in all the earth. You have set your glory above the heavens. Talk about evolution for a bit. I mentioned that some people believe evolution to be just a fact, but many modern scientists don't accept that blind chance and Darwinian evolution have brought us to where we are. And a few years ago, somebody came up with this statement: I'm skeptical of the claims for the ability of random mutation and natural selection to account for the complexity of life. Careful examination of the evidence for Darwinian theory should be encouraged. And so they sent this statement around, and they compiled a list of all these major scientists who agreed with that statement. Basically, and Stephen Meyer's book, The Signature in the Cell, really goes into detail of how the DNA and the cell and the biology is just not possible from blind chance, even given billions of years. So I want to talk for a few minutes about one scientist who doesn't believe, and this one believes very strongly in evolution and not in God. Some people might be able to guess who I'm going to come up with, but it's Richard Dawkins. He was one of the new atheists, and they were so called because they were very vocal in their atheistic beliefs, strident, one might say. And in 2006, he wrote The God Delusion, which it was a very influential book, actually. And it, unfortunately, philosophically, it wasn't very strong, but in a popular sense, it had a lot of influence. But Alistair McGrath, he's from the UK. He wrote a little book called The Dawkins Delusion. McGrath himself was actually an atheist early in his life. He was trained in molecular biology, but he converted to Christianity, and he's a member of the Faraday Institute. Michael Faraday is one of those early scientists I had on the list. And one of the chapters in McGrath's book is Religion Evil? And Richard Dawkins was well known for this. He would constantly say that we would be all far better off if religion was banished. But McGrath makes the very good point that if you look at the number of people that died in the 20th century, far more died from atheistic ideologies. You know, there was Stalin in the Soviet Union, Chairman Mao in China, the Khmer Rouge in Cambodia. They all banned religion. They all tried to squash it and have a completely secular society, but more people died at their hands than from anything else. And some of the most critical people of Dawkins were actually atheists. Michael Ruse is a atheist writer. And he was quoted as saying, "The God delusion makes me embarrassed to be an atheist." So another defender of the faith, one of my heroes, is William Lane Craig. He's debated lots of atheists. He's written many books. He's studied so much in the area of Christianity and science. Reasonable Faith is one of his, On Guard. And another hero is John Lennox. He's a professor of mathematics at the University of Oxford. He's written many books. He's been in debates. You can catch these two on YouTube for sure. John Lennox, William Lane Craig, especially in some of their debates. One of Dawkins' big questions in his God Delusion book was this question: who created God? And that's basically one of his, kind of at the end of the book, he goes into that. But John Lennox in a podcast says this: if you ask the question, who created God, it means you're thinking of a created God. We don't need him, Dawkins, or anyone else to tell us that created gods are delusions. We usually call them idols. So if there is an uncreated God, the question is silly. And of course, the central claim of Christianity is that God is eternal. Our God is uncreated. He has always been there. So you can't ask who created him. It's a silly question. So Richard Dawkins and other atheistic or materialistic people, they're well respected, but they're not philosophers. They're scientists. And unfortunately, some of these more famous scientists start to spout off about philosophy or other things, and that's when things can get out of hand. And even with Stephen Hawking, who was one of the greatest scientists in astrophysics and cosmology, in one of his last books called The Grand Design, it took him only a few paragraphs to dismiss all of philosophy. I'm sure there are a lot of philosophy departments in the world that were not too happy about that. So anyway, yeah. So one of my main messages, and I give this talk to young people when I can, that there are believers who are scientists. There's believers who are very eminent philosophers, Alvin Plantinga, for example, and you can hold your head up as a Christian. And I want to end with a very eminent scientist, and that's Francis Collins. He was appointed in 1993 to the National Center for Human Genome Research. And in June of 2000, ahead of schedule, they actually completed the mapping of the human genome. And later he was appointed the director of the National Institute of Health in the US. In 2006, he published this book, The Language of God. A Scientist Presents Evidence for Belief. It's a very, very good little book. And here's what Collins says: I'm a scientist and a believer, and I find no conflict between these worldviews. As the director of the Human Genome Project, I've led a consortium of scientists to read out the 3.1 billion letters of the human genome. As a believer, I see DNA, the information molecule of all living things, as God's language. And the elegance and complexity of our own bodies and the rest of nature as a reflection of God's plan. I've found there's a wonderful harmony in the complementary truths of science and faith. Again, he says, the God of the Bible is also the God of the genome. He can be worshipped in the cathedral or in the laboratory. His creation is majestic, awesome, intricate, beautiful, and it cannot be at war with itself. So we don't have to be afraid of science threatening faith. There are issues, there's complications, nothing is simple anymore these days. But there's excellent online resources. I've named several names here. And Francis Collins has the BioLogos organization, and they have a tremendous amount of material there for questions. So what we're basically saying is that the fine-tuning, the providential history of our planet, it all points to a creator. It points to a mind behind the universe that started it and takes care of it and tweaks it so that us humans can be here at this particular time in the universe on this planet. Nehemiah chapter 9 says, "You are the Lord, you alone. You have made heaven, the heaven of heavens with all their hosts, the earth and all that is on it, the seas and all that is in them, and you preserve all of them, and the host of heaven worships you." In John chapter 1, in the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things were made through him, and without him was not anything made that was made. These verses tell us that Jesus was right there at the beginning of it all. Isaiah 45, "Thus says the Lord who created the heavens, he is God, who formed the earth and made it. He established it. He did not create it empty, he formed it to be inhabited. I am the Lord, and there is no other." So God is the creator, the great designer, the supreme intelligent designer, the supreme fine tuner of this universe and of us. And Jesus, he is the truth and the life. As it says in John 14, I am the way, the truth, and the life. No one comes to the Father except through me. So they're searching for knowledge, both in life and in science and in theology. But the most important knowledge or truth is to know Jesus. And by doing so, to have life in his name. Because he's the one that without not anything was made. Not anything was made that he did not make. So he's the one. Amen.